Hello, I would like to demonstrate the LED driver in the VESC Express code. So what I have here on my desk is a VESC Express connected to two different LED strips. The reason I have two LED strips connected to different pins, even two different types of strips, is just for the sake of demonstrating that you can do that if you want to do that for some reason. So the long strip here has 45 LEDs. Those are 4-color LEDs with red, green, blue and white. And this one has 7 LEDs with only red, green, blue as color options. So this one also has one color that is white, that is actually a lot more broadband and not just the single components, which makes it look better if you shine light onto something with the LED strip, as you don't get weird reflections then. I also have two cameras, so I have one camera above the LEDs where I have turned down the exposure a lot so that you actually can see the colors. I mean, I didn't get it to show up that well. I probably need a better camera for this eventually that can connect to the computer and stream as a webcam. And then I also have another camera from the side here where just a normal exposure, and you can see on this camera, for example, the blue LED almost looks white because it's so overexposed. So you can use this one to see hopefully what the colors are, and this one what I'm doing, as I will connect some other things and try to use the IMU probably to control them in some way. So here is VESC Tool, the latest version from today, and I have updated the firmware on the Express, which is necessary because I've added some color manipulation functions that I will demonstrate here. So when you start, I would recommend going to the help menu or the help button, not the menu up here, it's a bit confusing, in the ListBM editor, and then open this link. And if you open this link, you will come to this page, and this shows all of the ListBM extensions that are VESC specific, and there are a lot of them, as you can see if you scroll here. If you look at the scroll bar and I just keep scrolling even fast, it just goes on forever. So there's a lot of VESC specific stuff here. The other thing that you should have open is the language reference. So you usually have this one open in a new tab in the browser. And this one is more specific to ListBM itself, so how to do concurrency, which built-in functions or fundamental functions there are, the different types, how to operate on lists and so on. And usually when I work on something I have both of them open. So one way to navigate those files, you see that you have this, I think it's a drawer icon of some sort, and this one will give you an outline of all of the titles. And it also has a search box here, so if you type here, it will filter the outline as you type, and then you can click on, for example, the RGBLED section. And this will scroll you to that location in the document, and you can still scroll up and down. And you can do the same thing here. So the RGBLED driver works like, actually let's show that in the documentation. So it works by loading it on a pin. It can be loaded on any pin, and it can also be reloaded quite fast. And the only argument the init function, or the one I call load now, the init function takes, is the pin number to use. If you initialize it on another pin, it will deinitialize it on the first one and start another one, and that goes quite fast. I think I measure it to take 0.3 milliseconds or so to move from one pin to another. So if you have many strips, you can alter between them. Then you also need an LED buffer, and the buffer stores all of the colors in the native format for the LEDs. So it's quite convenient to write to it, but it's not so convenient to read the colors back if you want to do modifications or manipulation on the colors. And the buffer is created with the RGBLED buffer function, and it takes the number of LEDs and arguments, the LED type, and an optional argument. Actually, the type is also optional. And then an argument for gamma correction. I will briefly explain gamma correction now, but I can also demonstrate it. So what it does is essentially applies a nonlinear transform on the color space. So for example, if you just, like the LEDs here do, if you just halve the duty cycle and the PWM, it will not look half as bright to us. It will look a lot brighter than half as bright. So in order to make it correspond a bit more to how our eyes perceive colors, you can apply a gamma correction. And if you give it this option when you create the buffer, then it will do so every time you interact with this buffer. Then to interact with the buffer, use the RGBLED color function. And the color function takes the buffer, the LED number you want to write to, a color, and an optional argument for brightness. Now, one thing here is that the color argument can be a single color or it can be a list of colors, and that is very important here, because what you should do when you manage your colors, you should not have a bunch of LED buffers. You should probably only have one buffer per LED or per LED strip that you have. In most cases, if you only have one LED strip, so only have one buffer. You can have more of them if you find some creative way of using them, but generally I don't think you should have more than one. And then you store your colors in lists. So you would make a list for all of your colors that you want to manage and operate on that list. And once you're done operating on the list, then you write it to the buffer and then update the buffer to the strip. So this color argument can be a list, and it will start applying those colors from the number you give it. So if your list is the same length as your buffer and apply it from position 0, then it will just update every single LED in the buffer. And there are some examples of that here. And next you have the RGBLED update function. So once you're done updating a buffer and you want to clock the data out to the LEDs, then you do RGBLED update and clock out the buffer. So that is hopefully simple enough, and hopefully it will be a bit more clear as I work on the demo. Here's also a small section on how to do multiple LED strips. And another section that happens to be quite just below the LEDs is the one called color manipulation. And this one is a set of functions to operate on lists of colors or single colors. And the color format is the same as you would have on any color picker or most color pickers or on web pages and so on. Just a 32-bit number, actually 24-bit number, or 32 if you have the white channel, where the 8 bits at a time are dedicated to each color. And you can type them directly as hexadecimal, but it's not super convenient, so then you have some functions here, for example, to make a color and with individual arguments for red, green, and blue. And these functions can work, for example, on just values right away, the bit values, or you can give it floating point numbers in the range 0 to 1, and it will convert them 0 to 1 to 0 to 255. And you can also mix them when you use them, so they're quite convenient to use. It will look at what kind of argument you gave it, and based on the type, update the color or create the color accordingly. And then you also have a corresponding one color split. So if you have a color, then you can split it into the individual components in different formats if you want to do something with that. And there are some examples of that here. So I think those two are quite straightforward. Then you have a color mix function, and this one takes two colors as arguments and a ratio, and it will mix them. So if the ratio is 0, it will give you color 1. If it's 1, it will give you color 2, and anything in between will give you a mix of them. And the way it mixes them is it splits them up into red, green, and blue, mixes individual components, and then puts them together again. Now, one thing that is important to know about the colors, the color function, except the make and split, that is the mix function, the add function, the sub function, and the scale function, is that they all of them work on individual colors or lists of colors. So for example, on mix function, and this is the same way, the first color can be a single color or it can be a list. So if it's a single color, it will return a color. If it's a list, it will return the list of colors, and then it will mix every single component in that list with color 2. Same for add and subtract and so on. And the scale function as well. And that can be useful if you want to make some global operations on your color vectors, such as fading them to some different color, or maybe showing a battery indicator that has some background color, and then you draw on top of the background color a list of your battery level. So yeah, let's see what we can come up with to demonstrate that. So that is the introduction to how that works, and now let's write some code and see if we can make something happen. So define there the LED numbers in strip 1 and strip 2 and made the buffers. And now we'll just demonstrate the small one, which is strip 2. So we do RGBLED init and initialize pin 21. And again, this function doesn't take, only takes the pin as an argument. And when you make the strips like this, then they will just be black from that point on. So we can do RGBLED update and strip 1 or strip 2. And if you run this now, I will use stream. You can also use Ctrl W to do stream. You can see that in the help text here, all of the keyboard shortcuts. The one I use a lot is the auto indent and the stream and the toggle comment shortcut, which you can comment out code with. So let's do Ctrl W, and as expected, nothing happens because they were off before, and we set them to off again. So let's do RGBLED color, strip 2, and see what the arguments were again. The buffer, the number, the LED number, and the color. So we'll do color make, and I will just make it no red, 200 out of 255 green, and no blue. So it should be quite bright green. And the LED you want to update is LED, say 0. And do Ctrl W, and you see this one turn green now. Okay, so we don't want to write directly to the strip. I mean, we could do that, but in this case we want to make a list with the colors. And in this case I will start by making a list of 4 colors, and I want to type them in manually. And I will just call it colors 1. And one very valid way of doing that is to make a list. I will quote the list here because we don't want to evaluate the list we type in, because that will be an error, so we have to quote it. Alternatively, we can use the list function and type the colors. And for this I could just take something like a color picker and pick the hex values, but in this case I want to use the color make function and define my red, green and blue elements as small sublists in this list, because that's easy for me to type. That's the only reason, and you can do it in more than one way. So let's try see how to write that, format that nicely. That's one of the slightly tricky things with LBM, to find out a good way to indent and format your code. It's not too bad. So I want to make, say, one that is no red, 100 green, no blue, another one that is no red, 200 green, no blue. And now if I run this code, see that I get this list in REPL here. See that I did that before already. And that works, but that is not the kind of list that RGBLED color takes, because if we don't want to have a list of small lists, we want to have a list with numbers that are RGB numbers. So one way to transform that list is to use the map function, which is a so-called higher order function. And all higher order means is that the function takes a function as one of the arguments, And the first argument is the function, and we create a function like this. A function takes one argument, and it has to return something. So we could return 0, for example. Now if I run this, I just get 2 zeros. I could do x, then I will get the same thing back, because I would just take every element and pass it to my function and give that element back and make a new list of that. And yeah, so you see how it works. So we want to use color make on that thing. Now I will demonstrate something here in the REPL if we do color make. So you see this works, but we cannot give it a list with those things because it doesn't take it. Now I gave it a list with all the arguments, but I want to give it the arguments. So one way to get around that is to use apply. Then it works the same way. Apply means use this function with this list as the arguments. And that is what we plan to use here. So we use apply, color make, x. Alright, let's see if that works. So now we got probably 2 colors here. And we can test that too and see if we got something that makes sense. I can just type it here. So we can, for example, do color split and do color split takes one color, but so let's do ix colors 1 take the first element, and you see that I get this thing back, which is it's this thing because this is the 0th element. So yeah, that works. Alright, so now we have colors on the list, and now we want to use this function on that list. Let's do stream, and now we have 2 colors. We said we wanted to have 4 of them, so we'll just do like, we'll do Control I on everything, the indentation. Control W, and now you can see that we have 2 dim LEDs and 2 brighter LEDs. Now I can demonstrate what I meant with gamma correction. So we can do exactly the same thing, and we can set actually there should have been colors 2 because it's strip 2 in this case. Same thing, but we don't want to be confusing when writing the code. So remove the gamma correction, do the same thing. And now you can see the issue here that you see that those 2 LEDs, they are brighter, but they don't look a lot brighter. They look a little bit brighter, but when you give it 100 versus 200, we want them to look twice as bright. So let's put the gamma correction back and move on with the next demo. Suppose we also want to show the same colors on this LED strip. And first I will just reinitialize the driver on pin 20 and run it. And you can see that we get the wrong colors here, and that is because we are using the strip 2 buffer, which has the wrong LED typeset. That is easy to fix. Use the strip 1 buffer and also write the colors to that one, the same ones for now. And you can see that we have the same pattern here, although they're a bit closer together. Now we can also add more colors. For example, you can do one this just white, and you can see it showed up on this one. It didn't show up on this one. You can also give it a bit of red to show that, maybe a bit more red, show that it also shows up on this one, but not the white part, because this one doesn't have the white color in it, so it will just be ignored on this strip number. You can also notice here that now we have one element that has 4 colors and the others have 3. And the thing is that color make function will take 3 or 4 elements, and the fourth one is optional. So when making the list here, it's quite easy to just even specify them in different ways. Okay, so let's move on. So I have renamed the thing called colors2 to pattern, reduced it to 2 colors. We don't want to light up too many LEDs because I'm driving everything from USB, and if I do that, this one will just overheat and it will reset the USB eventually. And I made a helper function that I called makeList that takes 2 arguments, one length and one width value, and I would just create a list that has this length with this value in every element, and it uses the map and range function to do that. And here I created a new list that I call colors1, and here I use append, and append just takes a number of lists as argument and merges them into one list. And here I take the pattern as the first part, and the rest, for the rest I make a list of 43 elements and set them to 0. And I could also say 40 number of LEDs minus the length of the pattern, but I will just type it manually for now. And you can see then we create a list that has these 2 colors and the rest zeros, and the length of that will be 45, as you can see. Let's make an effect where we spin that around, so we just want to rotate that list and plot it everywhere here. And this is also why I wanted to make it like this. So before, when we only had 2 lists, we would only set the first 2. Now we actually set all of them. So let's see, let's make a loop range from 0 to say 500. Copy this into that loop. Let's try the performance. So let's try to run this at 50 Hertz roughly, which means we should sleep for 0.02 seconds. That would be 50 Hertz. And for now this will just write the same thing over and over again. But let's use rotate on colors1 and rotate them I steps. Run this. And now you can see that we have this effect. It just spins around here. And it takes 3 or 4% CPU to do that. So not too bad. Okay, so let's do one more demo. So in this case we have colors1, which just is a list that is zeros for all of the LEDs. And we created one thread here. You can, by the way, you can use loop-wide THD to create a new thread that just keeps running here, and then your program will continue running from that. So Lisp BM threads are very cheap. And the first argument this one takes is the stack size for this thread. You can read about that in the documentation. And you can also, instead of using the loop-wide THD, you can also use spawn, and then you can make a function and use loop-while in that function. And this is just a macro that does that. So we have one thread, and this thread will update colors1 with the scale function and scale all colors by 0.9, meaning that if all of them will eventually scale back to 0, as it will make them smaller and smaller. And this thread runs 50 times every second. And then we have the old loop, or more or less the same loop, but we have wrapped it in another loop that just keeps going forever. And here we loop over all of the LEDs. And now in this buffer we set one LED to red, or the LED number I, so we loop from 0 to the number of LEDs, and we do set the last LED, or I minus, or the number of LEDs minus I, to blue, and update them. So the thing that this should do, if this works, is to have a rotating LED that goes in this direction with a trail that fades out slowly, that spins around, and another one that goes in this direction that spins around, that also has a trail that spins out slowly, that fades out slowly. So let's give that a try. So that doesn't look too bad. And you can see here we have one thread that runs 50 times every second, that fades every single LED out, or uses some multiplication on them with this operation. And we have another one that goes over all of the LEDs and updates them one at a time at 25 Hertz and sends all of those lit up LEDs to the LED strip. And together everything takes about 5% CPU. So that isn't too bad. And you can see it doesn't take that much code even. And usually, I mean, you can even remove this part here. Yeah, this is probably good keep, and then you can see all of the code it takes to do something like this. And here's another small mod on that demo. So we have so I added another thread, and we added a state called brightness. And as you remember in the RGBLED color, we have an argument that is an optional argument that is the brightness that is in a range from 0 to 1. And we also added the state that is whether the LEDs are on or not. And if they're on, then we'll step the brightness towards 1. And if they're off, we'll step it towards 0. So if we switch them off by running this line, you can see they will fade out slowly. And if we switch them on, they will fade in slowly. So that is one way to add another thread in a brightness state to have a smooth way of switching the LEDs on and off. And this is something that you can apply in the, if you would call it that, rendering thread here. And even adding this thread, as you saw, when we fade them in and out, it doesn't take a lot of CPU either. Okay, so this is the final version of the demo. I have added a few more effects, cleaned things up a bit, and added some comments, and I will push this one to my GitHub repository. So first in the file we have this make list function. I think I might have forgotten to mention it before, but it takes a length and a value, and it will make a list of this length populated to this value, and that is what we use to initialize the colors. Then we have, after this one, we have all of the variables, the global state that we have in this program, which is the number of LEDs, the strip buffer, the colors, and the on state and the current brightness of the LEDs. And then we initialize the driver. And then we have the thread that fades all LEDs towards 0, that runs all the time. I also moved the color and update functions into this thread, because if others don't stop updating, or for example if this thread that we had before that does the first animation would stop running, then the fading would stop as well. So I think it was, for this demo at least, made sense to have the thing here. Then next we have the thread that fades the brightness. Yeah, one more thing here, you see that I have this atomic block here, and that is because this one modifies a global variable that other threads also are modifying. And then you can get a race condition, meaning that when we start to evaluate this, then we start by evaluating this argument and run color scale on the colors. And after we have done that, someone might come in and modify colors after we picked it up from there, and when we write it back, that modification is lost. And that can happen because LispBM has preemptive multi-threading. So if this thread can be interrupted by another thread if it runs out of its quota. If you follow general functional programming styles, then you would avoid this kind of problem. But in this case, I think it makes sense to have a global state that is all of the colors that we have here. But there are many ways to solve the same problem. So anyway, that is how we do the fading, and this is the one that does the brightness when the LEDs are switched on and off. And then I made a function. So before I was just setting the color, but instead I used the color add function here, and I made a helper for that. And this is also atomic, by the way, because we're modifying the colors buffer. And this function will take an LED number and a color that is a list, and it will add that color to the chosen LED in the strip. So if it already has a color, it will just add them together, meaning that I don't know if you can see that now, but you see when they're kind of meeting here, then we actually mix the red and blue to get, I think that's purple. So that is the function we use to update LEDs. And then we run this animation thread. And now it just uses add color instead of doing this manually. And it doesn't do the update anymore because they're up here now. And then I added another animation thread, and this one just every 200 milliseconds will pick a random LED using the run function and doing modulo with the number of LEDs. So this will give a number between 0 and 44 for 45 LEDs, and we'll make it light up in green. And likewise here, that green LED will fade out, and that is why when you look at the camera here, we have those random green sparkles. And then I added one final thread here that every few seconds switches on and off the LEDs, and then you can see it fade in and out as that happens. I don't know if this is a good way to design like an LED system for whatever thing you're building. It's more of a demo, but it demonstrates that you can use different threads to work on the LEDs at the same time. You are using, for example, where is it now? The apply color function, and you're using the RGBLED color, the color scale function on a vector of colors, so it will do the operation on all of them. We're also using the update function on that vector or that list of colors, so we are doing many things at once and expressing the intent, and rather than spending time on doing every single update by itself. And we have in total 4 threads running now, or is it even more? One for the fading, this one for the brightness, this one for the first animation, this for the second animation, this for the switch on and off. So it's for 5 threads running at the same time. And we're running them at a decent rate, so we have an update rate of 30 frames per second now in the main thread that does the fading. So all of that happening together takes about 6% CPU for this amount of LEDs, and we have plenty of heap and memory to go still. So yeah, that is the demo. Hope that was helpful.